The best programming language to learn, in my humble opinion, in 2024 and in the next couple of years would be C and C++. Unless you are in AI/ML, in which case Python will be the best programming language. All other languages, JavaScript, Kotlin, Java, Swift, Objective-C, are nice to learn, but will not give you a decently stable software engineering career. Specifically, I would say firmware hardware programming for high-end computer chips is currently and will be the best niche that non-AI software engineers can break into in the next couple of decades to come. Just as good or even better than AI/ML, especially if you are an American citizen or a green card holder. There are 6 reasons for learning C and C++ over all other languages. The first reason is C and C++ are widely used for system-level programming roles in high-end chip companies, and these kind of roles offer reasonable career stability thanks to national security. Many positions involving low-level programming on advanced computer chips require the highest level of security clearance by the US government and many Western governments. Security clearance denotes authorization to access classified information or restricted areas following a thorough background check. It is essential for roles within the US government or entities handling national security. Essentially, needing the highest security clearance means the person must typically be a US citizen or in some case a green card holder. In other countries, this requirement may be termed differently, but I'm using US terminology here. This requirement significantly reduces competition for software engineering roles, particularly for individuals in countries with a strong presence in chip design and manufacturing, such as the United States and certain European nations, Norway, Sweden, and some Asian countries like Taiwan and South Korea. In the United States, security clearance mandates help protect jobs for American citizens against an influx of highly skilled foreign nationals. This is particularly pertinent for immigrants from China and India, who often face long waits, sometimes decades, to obtain a green card after their H-1B visa approvals. Currently, nearly half of all software engineers working in the United States are foreign high-skilled immigrants, with around 30% being Chinese or Indian high-skilled immigrants. If you are an American citizen thinking about getting into tech, your best career path in the tech sector, aside from government or defense contractor roles, is likely to be joining a company involved in chip design and fabrication. I used to work at Arista Networks, Google, and Tesla before, so I understand this. The chip fabrication software engineering teams in these companies that make the firmware and Linux device drivers for high-end chips, anything 4 nanometers and below, often would have to have very high security clearance, even if that high-end chips and hardware are not currently sold to the US government. This means the team members would have to hold anything from green cards to citizenship, and they also cannot have citizenship in certain countries such as Iran, North Korea, Syria, Sudan, Yemen, Somalia, China, Russia, etc. Countries that are on the US government's sanction list, and a couple more criteria. This list also depends on the role and company and industry though. When it comes to layoff, I have not heard of members of Google TensorFlow or Tesla Dojo firmware and system-level software engineering team getting the pink slips as much as headcounts from other more front-facing teams. Most Android, iOS, distributed systems, Golang roles got affected by recent Google and Tesla layoffs from my own network and observation. Previously, when it comes to national security, government focus was mainly on defense companies like Lockheed Martin and Raytheon. However, there has been a growing recognition of the critical role of the chip manufacturing beyond military applications. The US military heavily relies on chips supplied by foreign allies for essential functions. And here I'd like to show you an article on NSDXL. Talks about how computer chips became essential to national security. And it say about, national security relies on computer chips, right? And US companies still depends on South Korea or Taiwan. So essentially, the US government has recognized that chip manufacturing and chip design are very important to national security, even more so than hardware and weapons manufacturing companies like Lockheed Martin or Raytheon. And I would like to say that chip design and manufacturing are integral to the tech industry and defense industry future, irrespective of advancements in AI or large language models. There has also been a noticeable resurgence of chip manufacturing in the US with increasing job opportunities since around 2017. Essentially, the American tech sector and Silicon Valley are both going back to their original core competency, making silicon and powerful computing machines. Most of these investments are thanks to US government incentives and even mandates in some cases. Here I would like to show you an article. Samsung Electronics, they received $6.4 billion to build a factory in Central Texas. It is a fab factory in Central Texas. It was during the April 14th of this year. I live in Texas, so I knew this. They are expanding in Texas significantly. Essentially due to national security measure of the US government, chip design and manufacturing inside the United States is here to stay. The onshoring of chip design and fabrication will be a megatrend in the tech sector for decades to come, regardless of whether AI or LLMs succeed or fail. As long as threats against the US and Western allies remain in this world, Putin, CCP, North Korea, etc., I would expect US and other governments to increasingly strengthen their grips on the semiconductor industry and try hard to onshore as much as possible high-end chip design and fabrication processes. Absolutely nobody in any country or government cares about protecting their web developers, their Android developers, or their iOS developers. Android and iOS and web development are currently not of national security concerns in most cases and will very unlikely be national security concerns in the future. So if you are an American citizen watching this video, your best bet for a reasonably stable career in tech that is neither a government job nor a defense contractor job is to join a chip design and fabrication company. I understand that government jobs and defense contractor jobs, even though are both relatively more stable than Silicon Valley jobs, are usually lower paid with less perks. Software engineering job tied to chip design and fabrication is a great middle ground in pay and reasonable stability between government/defense contractor jobs and Silicon Valley jobs. Web and mobile, iOS and Android software engineers are dime in a dozen globally. As a web or iOS or Android engineer, you are essentially competing with software engineers from around the world, including third world countries who are willing to work 996 performance for a fraction of your 9-to-5 salaries. Even if you are out of job and even if you barely know C++, but if you have a little bit of experience with it, how about brushing up your C++ skills and try applying to one of these roles? The second reason to prefer C++ low-level system programming for high-end, not low-end semiconductor companies over other niches in the tech sector is economic protectionism. When talking about protectionism, many of you may think of the UAW or Auto Union Worker and the United States government bailout of the auto industry in 2008. But for me, protectionism now means Intel Corporation. Literally, our entire modern way of life, from toilet papers to electricity to the internet, etc., is dependent on semiconductors and chip design and manufacturing. The entire tech sector depends on it for sure. The US economy would collapse similar to the Great Depression if a war between China and Taiwan break out. And the US government, they know this very well. Recently, the US government gave out a loan in accordance with the CHIPS Act to Intel Corporation, the biggest loser in the US semiconductor industry. I think Intel is getting kicked out from the Dow Jones and replaced with Nvidia or something. Right, so here this article is say Intel awarded up to $8.5 billion in CHIPS Act grants with billions more in loans available. And then, right after the loan was granted, Intel still had to cut 15,000 jobs or 15% of their workforces. That's a huge amount. Biggest loser in the semiconductor industry right now. The layoff is Intel specific though. They are facing stiff competition from AMD, Nvidia, TSMC, etc. This is not a sign of weakness from the semiconductor industry. It is not an industry-wide layoff, but rather just Intel is doing it while the rest of the industry are on a hiring and expansion spree, thanks to AI and geopolitical protectionism. There was a research paper put out by Deloitte showing that the semiconductor industry will face a steep labor shortage of 1 million people by 2030 globally. And globally here actually means Western and Western aligned countries, and mostly US shortages. Due to national security and economic protectionism, China is barred from acquiring advanced toolsets and fab/lithography machines to make advanced computer chips. Now, there was another research put out by Korn Ferry in 2018, and this was before the AI bubble, predicting skill labor shortage would reach 4.3 million workers in non-China countries. So looking at both of these reports, semiconductor high skill labor shortage will be 25% or one-fourth of the total amount of high skill labor shortage in the tech sector of Western countries. And that is a huge number. We have dozens and hundreds of industries within our tech sector, and semiconductor high skill job shortage will be one-fourth of that. There's also another article that I would like to show you. It's called The Unsexy Engine That Will Save the Future of Tech Work. And it's say about why semiconductor industry might be the best employer yet. And it is true because this article talk about the year of efficiency, right, of Mark Zuckerberg, and more than 225,000 tech workers have lost their jobs per layoff, FYI. And the reason for this is the tech industry in the West is shifting towards its route, which is designing chip manufacturing silicon. Essentially, I believe in the next couple of decades, it will be socialism for the semiconductor industry and capitalism for the rest of the tech sector. To be honest, nobody will give Zuckerberg a loan to save Instagram, okay? Same with Google, Amazon, etc. Humanity will be 100x better off with Meta going bankrupt. But if AMD, Intel, Supermicro, TSMC are in trouble, US government will be printing trillions of dollars to save these companies, indirectly taxing the entire nation through massive inflation, because they have no choice. If Uncle Sam is willing to bail out a zombie like Intel, Uncle Sam will of course bail out Nvidia, AMD, Supermicro, etc. if they are in trouble. If high-end chip companies go bust, they will get bailed out. If Facebook and Instagram go bust, nobody cares. That has been the landscape of the tech sector since 2015 and will be for the foreseeable future. The reason that this type of bailout happens is because chip design and fabrication are quintessential for the modern economy, much like energy. So even if there are layoffs and economic depression going on, software engineers and firmware engineers in these chip companies will largely be safer than non-chip companies from these layoffs. In the case of an economic recession, these companies will easily be able to get loans from the government, and the rest of the tech sector will get massive layoffs after layoffs after layoffs for eternity. Similar to the case of the Big Four auto manufacturer, it is less likely that semiconductor industry would witness huge job cuts industry-wide in catastrophic events, especially compared with other industries within the tech sector. With the current geopolitical climate and tension between Taiwan and China, I would expect the US government to increasingly force chip fabrication and production to move inside the United States and away from Taiwan/South Korea, which means we're about to see a hell of a lot more sub-10 nanometer and even sub-4 nanometer chips being designed and manufactured in the United States. The 2 nanometer is largely manufactured in Taiwan at the moment, but the US government is forcing Taiwanese chip makers to build plants in the US. And here I'd like to show you the 6.6 billion Arizona hub, April 2024, that Biden signed. It is a $6.6 billion grant to Taiwan top chip manufacturer to produce semiconductor in southwestern US state of Arizona, right? Which includes a third facility that will bring foreign tech giants investment in the state to $65 billion. So TSMC already invested billions of dollars in the US. This is like another 6.6 billion grant for them to build plants here. And I believe in the next 5 to 10 years, most sub-4 nanometer chips will be designed, manufactured, programmed inside the US by American engineers and not by Taiwanese engineers. This will bring lots of chip design and manufacturing jobs onshore to the US, while in turn give some slight job protection to system-level software engineers and firmware engineers working for high-end chip companies. When the entire semiconductor industry is growing and having government backing and taxpayers bailouts, it is less likely that significant industry-wide job cuts would happen even in severe economic recession, at least in the short term. It is almost like the government has become the union for the workers of the semiconductor industry. The third reason for choosing low-level programming roles for high-end chip design and fabrication companies is Western competence and monopoly in chip fabrication. When we discuss why the West is ahead in software today, we have got to look back at how we got here. Our edge in semiconductors. Companies like IBM, Sun Microsystems, and Bell Labs were pioneers. They did not just create computer hardware, they laid the groundwork for what we now call modern software. Back then, they were setting the stage with chips that powered the first personal computer and the early internet. We had computers, personal computers, DSL, high-speed internet, and cell phones before the Japanese and most of Asia, including the Chinese, who are definitely way ahead of the Russians in terms of semiconductors. That early head start in semiconductors is the reason why we seemingly have world-leading software industry nowadays. But what if things had gone differently, right? What if those groundbreaking companies were based in China instead? Would our coding languages today have Chinese syntax? Our early lead in semiconductors gave birth to essentials like Java and JavaScript, which are now the backbone of apps and websites everywhere. Western software superiority is not as straightforward as it seems. Sure, Western giants like Google and Meta dominate now, but that's largely because we had a head start with semiconductors. Without that early advantage, Chinese tech companies might have shaped today's digital landscape in a completely different way. China did not lead in semiconductors due to historical reasons. During the Cold War, China focused more on heavy industry and agriculture, which slowed down its entry into advanced tech industries like semiconductors. Also, at the time, there were already technological and geopolitical barriers that kept China from accessing cutting-edge semiconductor technologies from the West. In recent years, Chinese innovation in software development has been remarkable. Chinese developers have created and significantly contribute to frameworks like Vue.js, which is known for its performance and ease of use in building user interfaces. They are also contributing significantly to many popular libraries in the JavaScript ecosystem, HTMLX, etc., and even Flutter, reshaping how apps are built worldwide. If you look at Vue.js, it is extremely performance focused because most Chinese apps on the App Store and most WeChat mini programs are either mostly web views or PWAs. And so JavaScript performance, especially on mobile, is of extremely concerns for Chinese apps, with WeChat being a prime example. Essentially, their entire ecosystem is WebView and PWA, with the main WeChat app being the native platform, with some of the best, if not the best UX design in the entire app ecosystem. From real experience and most benchmarks online that I have seen, Vue.js performance usually blows React.js out of the water, which is very important in developing mini programs in WeChat and smaller programs running on Chinese low-end Android phones. Developing in Vue.js is also a joy and nowhere as miserable as Angular development. Here I would like to show you a video where Elon Musk said this himself, that he would like Twitter to copy WeChat design and become a super app.
We don't even have an app that's as good as WeChat in China. And like in China, you can live on WeChat basically.
Yeah.
It's like, everyone's like, you live on WeChat, you do payments, you do everything. It's like, it's great. Basically, WeChat's kick ass. And we don't have anything like WeChat outside of China. So I was like, my idea would be like, how about if we just copy WeChat? Hey, copy them.
Buys Twitter, copies WeChat.
Yeah, pretty much. Yes.
So essentially from this video you can see that we are leading the world in software development in general. I mean non-semiconductor software development, but we are not dominating the world. So I would like to give you an example for myself. So if you go outside the United States, you go to any other countries that are not Western countries, and if you use iPhone, you can change the location of your app store to that particular country. For example, if you are in Thailand, change your location of the app store to the region of the app store to Thailand. You use an Android, you can change your region to South Korea, for example, right? And you see that in the United States, the top 10 apps, 9 out of 10 are American made. If you go to Europe, 8 out of 10 apps are American made. But if you go to, say, any Asian countries, you switch the region of your app store, the top 10 apps, probably less than half, would be American made or Western made, and the rest would be like either locally made or Chinese made. So you got to understand, like, we are not dominating the App Store worldwide. That's number one. And number two is we seemingly lead in software development in JavaScript, iOS app, web apps, etc., because we have a lead in semiconductor. You know, if China catch up in semiconductor manufacturing, that is the day that they would actually surpass us globally in terms of software development and software market share. I mean, the day that China overtakes us or catch up to us in semiconductor manufacturing also means that you will see a lot of Chinese apps dominating globally. And as I speak right now, we lead the world in App Store, we lead the world in Google Play Store, but we are not dominating. We are not like 80% or even like 50% of the world leading apps. Western countries no longer hold the edge or no longer hold the superiority in software development. And our strength is not actually in software development as in like app development. Our strength in Western countries is actually semiconductor manufacturing. The lead in semiconductor and the domination in semiconductor design manufacturing will ensure that, you know, Western countries dominate in software in the long run. Also, I mean, you know, if you look at some of the numbers, China also has the highest number of STEM graduates in the world, 3.57 million STEM graduates compared to even India. I think India is more populous, but they have like 2.55 million. And you may say, oh, you don't believe Chinese numbers. Okay, even if you cut these numbers in half, right? 3.57 million, you cut it in half, it's still like 1.75, 1.78 million, which is still the second highest amount of STEM graduates in the world. It's understandable that they would eventually dominate in software development. In terms of semiconductor manufacturing, it will take a while because of all of the embargo, all of the tariff, all of the sanctions imposed on China. You know, so it will take a while for them to catch up in semiconductors. But in terms of like software, like app developments, I think Chinese developers are already there and already surpassed, you know, many Western countries. And I would like to give this from my personal example. So when I was working at Tesla, the best team at Tesla, and you probably already know this, but this is public news. The best team at Tesla is Tesla Shanghai, and they dominate in absolutely every single metric, right? They dominate in, except for FSD, because FSD is Fremont based. The Shanghai Tesla software teams, they dominate in every single metric, like compared to any other factories, compared to Fremont, Nevada, compared to Austin, Texas, from the output to the quality of the software, the number of bugs, number of tests, number of rollouts, customer retention, etc., etc. When I was working at Google, it was the same thing. Google don't do business in China anymore, but they have like an office in China. I think it was in Beijing and Shanghai, and they do like Android specific customization for the China market. The teams there were really good people, really great engineers there, and made some of the phenomenal contributions to the Android ecosystem. I mean, even if you look at Flutter, Chinese developers contribute a lot to the Flutter framework, especially ByteDance. We owe a lot to IBM, Sun Microsystems, Bell Labs, Netscape for innovations like Java and JavaScript. Those were pivotal in establishing our software dominance today. Without these companies helping the West maintaining the lead in semiconductor and personal computers design and manufacturing during the 1980s, Linus Torvalds would probably be a Chinese or maybe a Japanese. Even when we talk about app development in the West, 30 to 50% of tech workers in the West are foreign talents imported from China, India, Vietnam, Thailand, etc. Your Facebook, Instagram, TikTok, etc. are mostly built by foreign talents like me, not American-born citizens like many of you watching this video. Tencent and ByteDance developed some of the best libraries in the community. ByteDance makes huge contribution to Flutter. The fourth reason to learn C and C++ and pursue a career in chip design and manufacturing software engineering jobs is entry-level friendliness. Due to the current economic recession, companies are increasingly raising the bar for entry-level and mid-level interviews, especially in the product design or system design rounds at big tech firms. In contrast, entry-level software engineers often find it easier to navigate operating systems interviews at top chip design and fabrication companies, where the requirements for technical depth may be more aligned with academic preparation rather than extensive practical experience. At chip companies, operating system interviews mostly drill down into technical knowledge that is closely tied to what you learn in school. We are talking about diving deep into low-level programming, memory management, and concurrency. The questions are detailed and specific, designed to test how well you understand these core OS principles. However, when you look at system design interviews at big tech or startups, it is a whole different game. These interviews demand hands-on experience, the ability to make tough decisions on architecture and trade-offs that typically come from real-world challenges or higher-level roles. It is about dealing with the complexities of distributed systems where practical experience really counts. Operating systems interviews benefit from their precision. Interviewers ask direct questions that cut right to the heart of OS design principles, leaving little room for uncertainty. On the flip side, system design interviews can be trickier because of the broad scope of distributed systems. It is harder to standardize questions and evaluate candidates consistently across different system design interviews. So from my own experience, working at different companies, the system design interviews that I give as an interviewer, and sometimes that in my own interview as an interviewee, vary greatly. So some companies, some teams, they will delve into different aspects of the questions, and the quality really vary. Right, so there are not very good system design questions, and there are great system design questions. And this is not the topic of this video, so we'll leave it for another one. But essentially, system design interviews quality vary greatly because it is open-ended. So it is not as standardized as operating systems or firmware or low-level system interviews. And I have worked at both hardware companies, Arista Networks, and I have worked as distributed system and back-end, front-end, full-stack engineers for Tesla and Google, so I understand this. Entry-level friendliness is not only beneficial for new engineers or college grads, but also plays a strategic role in the career progression of senior engineers aiming for promotion. In most companies, it is rare to find teams composed solely of senior engineers, except in unique cases like Netflix or environments tainted with internal politics and title inflation. Now, you might initially think that increasing entry-level friendliness could intensify competition for jobs and potentially hinder senior engineers. However, the reality paints a different picture. Here's why balanced team composition is crucial. Number one, in a team that includes both entry-level and seasoned engineers, there is a dynamic interplay that benefits everyone. Senior engineers have the opportunity to demonstrate leadership and mentorship, fostering a collaborative environment where knowledge sharing and skill development flourish. Number two, entry-level engineers bring fresh perspectives and enthusiasm, injecting innovation into the team's problem-solving approaches. Their familiarity with the latest academic insights and emerging technologies complements the deep technical expertise of senior engineers, leading to more robust and creative solutions. Many entry-level engineers actually hold masters and PhDs, by the way, especially if they are from foreign countries. Most of them study undergraduates in their own countries and go to the United States to pursue higher education. The fifth reason to study C and C++ and pursue a career in firmware development and low-level software engineering in high-end chip companies is the balance between job security, decent pay, and work-life balance. Firmware and low-level software engineering in general have better work-life balance than web or mobile development. The work-life balance in general is worse than government jobs, of course, but better than web or mobile or DevOps developments in most cases. First, low-level programming often involves longer and more predictable development cycles compared to the fast-paced nature of high-level software development. In firmware or embedded system work, the development process typically follows a more structured timeline. Unlike software startups or companies with rapid iteration needs, the goals and timelines in firmware development are often well-defined and stable. Even when it is adjusted, the deadline and the timelines are adjusted, usually they are extended forward and not being contracted backwards. So, if the deadline change, it usually change to become longer and not change to become shorter. This predictability leads to a more manageable workflow and fewer last-minute crises. Furthermore, the need for urgent releases or hotfixes is generally less frequent in low-level programming roles. Firmware updates usually require extensive downtime, reboot, and can easily break the system. Thus, low-level software and firmware usually have longer development cycle with very rigorous testing. The move fast and break things mantra usually don't stand the test of time in the semiconductor and chip manufacturing industry. And thus, once low-level software, firmware, and hardware design are completed and tested, they tend to remain stable for an extended period of time. This contrasts sharply with the high-level application development, where frequent updates and patches can lead to unpredictable work hours. In low-level programming, the stability of the final product means that professionals are less likely to face late-night emergencies or unexpected deadlines, contributing significantly to a balanced work schedule. And you can definitely see this from the recent CrowdStrike and Microsoft outage problem, which grounded many flights all over the world. The software team at CrowdStrike and Microsoft probably were under fire here because they probably would have to work late nights, 24/7 during the outage because of the software rollouts. Additionally, low-level programming roles usually require less on-call support compared to high-level software positions. In many cases, embedded systems, once deployed, require minimal immediate intervention. This reduced demand for 24/7 availability means that professionals in these roles experience fewer disruptions to their personal time, which is a key factor in maintaining a healthy work-life balance. From my personal experience, I can attest to the benefits of this work-life balance. In my tenure at Arista Networks, a networking company that makes AI-driven networking equipment, I found that the predictable nature of low-level software development allowed me to maintain a steady and manageable work schedule. Software written in the company follows strict test-driven development and SDLC software development lifecycle and the best industry practices. They did not make shortcuts, nor doing things like hotfixes, nor applying band-aid solutions to deep-rooted problems like what you usually would experience in customer-facing, web or mobile development team in many companies, big and small. The structured project timelines meant that I was not frequently subjected to urgent changes or high-pressure deadlines, which contributed to a more balanced and less stressful work environment. Industry trends also support this view. Many companies in the semiconductor industry emphasize their commitment to employee well-being and work-life balance. The structured development cycles, infrequent urgent releases, and reduced on-call demands contribute to a more stable and manageable work environment. The final reason to double down on C and C++ and pursue a career in firmware programming or low-level programming for high-end chip companies is AI-proof. And by AI-proof, I mean 100% AI-proof. The firmware and system-level development processes are also unlikely to get replaced by AI anytime soon, since most tools used by these companies are proprietary and not open source. If you talk about AI replacing software engineers, the first jobs to go would be those that use the most open source frameworks and open source technologies with millions of code lines available on GitHub, the like of React.js, Angular, or Android development or iOS development. There are lots of code lines online that can be used to change AI on these frameworks and languages. High-end chip design and manufacturing and firmware development toolsets are almost fully proprietary by nature and does not have tons of GitHub repositories for AI to scrape data from. Not even chip manufacturing, but even networking firmware and low-level software development in general use tons of proprietary technologies. Even their open source offerings such as AMD HIP or HIP are not fully open source, not until at least recently. And even if they want to make something open source, I will not be surprised that they may have to get approvals from the US government in the future. This increasingly closed ecosystem restrict access to the data and methodologies that AI would need to effectively automate these tasks, ensuring that human engineers remain essential in semiconductor software and firmware development. I have worked at both low-level programming roles for hardware companies and software front-end as well, as well as back-end roles for Web 2.0 companies, so I understand this. One example I can give is a company I used to work for, Arista Networks. They use a closed-source proprietary programming language and framework called Taxi. And here I would just like to show you the article. This is the name of the framework. It's Taxi. I would say that Arista Networks is one of the more open source networking and data center equipment manufacturers out there. I would bet that Cisco, Qualcomm, Samsung, Apple, etc. use tons of proprietary custom-made tools within their chip design, and also within their manufacturing and low-level programming teams. This makes it near impossible for popular public AI agent or LLMs to replace software engineers in these companies in the foreseeable future. I would say 10 to 20 years at least, which is enough for me to retire. Even if these companies train the AI themselves on these proprietary languages and libraries internally, in aggregate, the amount of total code lines and logic written using these proprietary tools in each of these companies is much less than, say, React.js or Java Spring code on GitHub and other public domain. Now here's my opinion in terms of choosing the best path and specialization for your tech career. A lot of time, people, especially my tech YouTuber friends out here, tell you what particular companies you should apply to, how to get to FANG, etc., stuff like that. But I would say that whether you choose to start a company, side hustles, or getting a 9-to-5 job, you should select industry and not companies. Also focus on learning the skills and specialized knowledge that are transferable to the rest of the industry and not just specific to one particular company, if possible. A company's fate is largely dependent on its C-suite management. An industry or even sector is largely dependent on collective innovation and geopolitical competition. Never bet your faith in one company, but an entire industry. When choosing which core set of technologies to learn, you should learn something that is applicable to an entire industry that will grow in the foreseeable future, thanks to unchangeable cultural, geopolitical factors and circumstances. If the sector or industry is growing, will the things that drive the growth stay constant and stable in the medium or long term? Or is it just a fad? That is the questions you should ask when it comes to your career direction. Please remember that we are living in an increasingly more and more polarized and deglobalized world with no end in sight. Never bet your entire career on one company or choose a career direction just because the biggest company in that sector or industry looks cool or sound good or is part of some stupid ego-boosting acronyms like FANG, Fanta, Manga, Mach 7, etc. Those acronyms, by and large, are just Jim Cramers and Wall Street utter garbage. The recent Intel mass layoff of 15,000 employees, or 15% of their workforce, happening during a period of aggressive hiring in the rest of the semiconductor industry, is a testament to what I just said. Intel may be laying people off, but the semiconductor industry as a whole will grow leap and bound in the West, especially in terms of job number due to geopolitical competition and protectionism. The employees who are laid off from Intel this time are by and large luckier than their laid off peers in the web and mobile development during the 2023 and 2024 layoff season. Because non-semiconductor roles layoff at the beginning of 2023 and 2024 was companies trying to cut costs across the board to prepare investment for AI and optimize for shareholders' value. The 2023 and 2024 tech layoffs happened to the entire tech sector, hitting web and mobile and distributed system roles extremely hard. In my opinion, the layoff at Intel, as well as most recent earnings from semiconductor companies, as well as geopolitical struggles of Western countries versus China, do not indicate a semiconductor industry-wide layoff, in the short term at least. Intel is no longer the entire semiconductor industry, far from it. And the entire semiconductor industry is not just Intel. If you are looking for a career that offers real job security, solid pay, and a decent work-life balance, firmware and low-level software engineering in semiconductor companies is where you should be heading. Forget the flashy promises of high-risk web apps or startups or the overhyped allure of AI and machine learning. C and C++ programming for high-end chips is the real deal for anyone serious about their career. Semiconductor companies offer unmatched stability compared to the erratic world of tech startups. Jobs in this field are less likely to be outsourced or automated away, thanks to the highly proprietary nature of the toolset and the high level of security clearances often required. This is not just about keeping your job, it's about securing a role that stands strong against economic downturns and technological disruptions. Furthermore, the semiconductor industry is getting a significant boost from both economic protectionism and a resurgence in domestic manufacturing, which means more opportunities and a firmer foothold in the industry. Entry-level positions are also more accessible here compared to the often grueling demands of tech giants or the volatile nature of other sectors. So if you want a career that is stable, pays well, and has a clear path for advancement without having to get like a 7 or 8 years PhD in AI, diving into firmware and low-level programming for semiconductor companies is a smart move. It is a field that combines job security with meaningful work, making it the best choice for anyone looking to build a solid long-term career in tech. And that will do it for me today. Thank you for watching the video. See you in the next one. Bye bye.